Okay, so this is going to be the most difficult code of all. I'll tell you up front, some of you are going to get real frustrated or just be like, I don't get this. It's tricky, but once you learn it, you'll be like, oh, not only are you going to learn a code, you're actually going to learn something very deeply fundamental about computers. So let's dive in. Okay, the pretest. What is going on here? All right. This is a code that only uses two things, 0 and 1. And I'll tell you a big secret. Computers understand this code. As a matter of fact, it's the only thing computers understand. See, computers only understand zeros and ones. We humans understand words and letters and numbers and all that stuff, but computers only understand 0 and 1. They really understand on and off, but we're not ready for that yet. So let's start here. Okay. This is a special code, if you couldn't guess, called binary. Now, bi means two, right? Like bicycle, biplane, things that have two, like a bicycle has two wheels, right? B-I, bi. Okay, so bi means two. Binary is a code where you only use two numbers, 0 and 1. In binary, there's no other number. See, we humans use what's called base 10. When we write a number, we'll be like, oh, the number 37 is 37. Okay, in binary, there is no 3. There is no 7. The weird thing about binary is using only the numbers 0 and 1, we could write any number in the universe. But we got to know the trick. So let's try writing the number 37 in binary. I feel like we're going to need a cheat sheet to help us. So I made a cheat sheet. Now all these down here are examples that you can look at later. We said we wanted to write the number 37 in binary. Okay, so here's 37 in just regular human base 10 numbers. 3 in the tens place, 1 in the sevens place. Literally, we have 30 plus 7. I bet you've seen your teacher do that once or twice. An expanded form, right? 30 and 7 makes 37. Okay, well, in binary is this kind of crazy thing. If I wanted to write the number 1 in binary, I would write a 1. If I wanted to write the number 2 in binary, I would write 1, 0. Wait, what? That's the number 10, Mr. Rainey. Not in binary. See, the kind of crazy thing about binary is each place value in binary is worth double the place value before it. See how it says number in base 10, 1, 2, 4, 8, 16, 32, 64, 128. By the way, this could keep going. 256, 512, 1024. Okay, I ran out of space. But notice how each of these numbers is just a double of the last one. 2 is the double of 1, 4 is the double of 2, 8 is the double of 4, 16 is the double of 8, 32 is the double of 16. It just keeps going, right? Everything doubles. When we write in binary, we use that doubling trick to help us figure out what place value we're in. See, right here, let's write out some numbers in binary. If I want to write the number 0 in binary, I just write a 0, right? Because, hey, I'm in the ones place here. I'm going to say a 0, okay? What if I wanted to write the number 1? If I wanted to write the number 1 in binary, it's going to look very familiar. I'm going to take this place value right here and just write a 1 in it. That's the number 1 in binary. Okay, if I wanted to write the number 2 in binary, well, if you notice, the next place value over is worth 2. So in binary, I would say, oh, I have a 2, and I have nothing in the ones place. So in binary, the number 2 would be 1, 0. Our human brains want to be like, that's the number 10. See, over here, that would be true. In our base 10, we'd say, yep, that's totally true. That's the number 10. But see, over here in binary, we say, nope, that means 0 in the ones place and a 1 in the twos place. Okay, how would we write the number 3? Well, let's see here. I would need a 2 and I would need a 1. 2 plus 1 equals 3, right? Okay, true. So in this weird binary thing you're teaching us, 2 plus 1 equals 3. So binary 3 would be 1, 1. How would we write the number 4, Mr. Rainey? See our place values? 1, 2, 4. Oh, I see a 4. That must mean I would put a 1 here. Because remember, in binary, I only get 1 or 0. So I put a 1 here to be like, I'm going to put a 1 in this place value in the 4's place. In the 2's place, I don't need anything. In the 1's place, I don't need anything. In binary, the number 4 would look like that. 1, 0, 0. Once again, our human brain wants to say, oh, that's the number 100. Not in binary. In binary, that would just be no 1s, no 2s, 1, 4. So in binary, we would read that as 1, 0, 0 or 4. Okay, if I keep going, 5, well, what would 5 be? Now, if you notice, I don't have a 5's place, do I? I have 1, 2, 4, and then 8. So I guess what I would need to make the number 5 is I would need a 1 in the 4's place. I don't need a 2, but I do need a 1 in the 1's place. Oh, 4 plus 1 equals 5. In binary, 1, 0, 1 is 5. Okay, now this keeps going, right? So now to make a 6, same thing as before, a 1 in the 4's place, a 1 in the 2's place, because 4 plus 2 equals 6, and then I don't need a 1 here. So 1, 1, 0. Now, if you're hanging with me, you might start to see this like, oh, okay. So like these 1s and 0s, they make combinations that you just add up and then you get to the big number that you wanted to write in like regular numbers, right? Yeah, I mean, that's pretty much it, right? So here's my question for you. How would you write the number 7 in binary? I know 1, 1, 0 is 6, right? 4 plus 2 equals 6. So how would you write 7? Would you need to change anything? If you're yelling at your computer right now saying, yeah, Mr. Rainey, you'd put a 1 right here because that shows you need a 1, right? 4 plus 2 plus 1 equals 7. Oh, so 1, 1, 1 in binary would be 7. Okay, that's very smart of you. How would you write the number 8? If you can write the number 8 right now, I think you have a pretty good, because once you figure out 8, you could write 16 or 32 or whatever. How would you do the number 8? What would you need to do to show 8? If you're screaming at the top of your lungs, don't do that. You might get in trouble at your house. But if you're screaming at the top of your lungs or in your brain saying, well, Mr. Rainey, there's an 8 right here. You'd put a 1 right there to show, oh, I need a 1 in the 8's place. I just show like I have an 8. And then I don't need any of these other things to make 8. It's just, to the person walking by on the street, they see the number 1,000. To the computer or the human who understands binary, they know, oh, let's see, 1, 2, 4, 8. That's in the 8's place. That's an 8. All right, and now from this point forward, if you're still with me and you get this, you know binary. 9, what would it be? Well, I need 8 plus 1 more, so I'm going to take this and turn it into a 1, and that's 9. Not 1001, 1001. 1, 2, 3, 1, 2, 4, 8. 1 plus 8 is 9. This is how computers think. Computers don't understand the number 2 or 3 or 5 or a million or a trillion. They understand 1 and 0. And so when we send a computer a message, hey, add 3 plus 5, what a computer is really doing is we type in 3 plus 5, but what the computer gets is 1, 1 plus 1, 0, 1. Computers don't understand 3 and 5. They understand binary. And now you do too. So let's do one more. So we counted like 0 to 9, right, in binary. How would you write? Let's pick a big number. Let's see if you can master this one, you got it. The first part. How would you write the number 50 in binary? Okay, that's way bigger than any of the other ones we did, right? So how would you do that? Okay, I know for a fact I don't need 128 and I don't need 64. Those are too big, right? I'm going to cross those out. Okay, I bet I need a 32. Now, let's see here. What would 32 plus 16 be? I'm pretty good at math. 32 plus 10 would be 42. 42 plus 6 would be 48. Oh my gosh, that gets me really close to 50, right? 32 plus 16 equals 48. I only need 2 more to make 50. I don't need an 8, I don't need a 4, and I don't need a 1. Wow. The number 50 in binary would be this: 1, 1, 0, 0, 1, 0. That's the number 50. I'm telling you, if you if you walk to someone who doesn't know binary and say, "Hey, did you know that that number equals 50?" They'd be like, "No, it doesn't. You're insane." But if you know binary, you know that it does. You just have to know the trick. You have to know the trick. So this thing right here, this is the trick. And so I'll show you in a few minutes here. I'll be nice. You can calculate any number in the known universe with binary. You might need to keep adding row. You might keep like doubling 128 would be 256. You keep doing this, and you could write any number in the galaxy that you wanted to this way. Okay, now we're going to stop this video here because that's a handful. That's a lot to take in. I'm going to show you a shortcut on how to do things in binary because it's fun to. I think it's fun. I'm kind of a dork to like know how to write things like this out. But then it's also nice to know, hey, there's a faster way to do it. So in the next video, I'm going to show you a faster way, and then I'm going to show you a secret language we can use that computer. By the way, it's not that secret. Computers use it every single day, but it's secret to the average person. So we're going to talk about how you can use this to write your own secret code.